All right, thanks for watching. And today I want to show that the function square root of x is continuous. So let f of x be square root of x, and let's show f is continuous at x naught. And the case x naught equals 0 is separate, and I'll deal with it at the end because it's much easier. So for now, let's assume x naught is positive. And again, what do we need to show? We need to show that for all epsilon, there is delta such that if x minus x naught is less than delta, then f of x minus f of x naught is less than epsilon. All right, so step one. Again, finding Nemo, so finding delta. Well, so let's just consider the difference. So f of x minus f of x naught, that is just square root of x minus square root of x naught. And then you just multiply. You see you have a difference of square roots, so you just multiply by the conjugate form. So that becomes, if one, square root of x minus square root of x naught times square root of x plus square root of x naught over square root of x plus square root of x naught in absolute values. And then the numerator you can put together, so square root of x minus square root of x naught times square root of x plus square root of x naught. And also the denominator, square root of x plus square root of x naught. But notice this is positive, so no need to put absolute values. Now, the numerator becomes a minus b times a plus b, which is a squared minus b squared. So this is just square root of x squared minus square root of x naught squared, absolute value, over square root of x plus square root of x naught. But then, how nice is that? This just becomes x minus x naught over square root of x plus square root of x naught. And remember, this is the stuff that we want, right? This is the stuff that where delta comes from. And ideally, we want to make this independent of x, but that's not a problem because remember, x is non-negative. So in fact, this is less than or equal to x minus x naught over square root of x naught. Now, one little thing, if x naught were 0, that would be a problem because we would divide by 0, but I said we don't assume x naught is 0. And now, last but not least, all you need to do is set this less than epsilon, and you get in the end that x minus x naught is less than square root of x naught times epsilon. So this is our delta. So now our actual proof, let epsilon be given, and then let delta to be square root of x naught times epsilon, which again is positive. Then if x minus x naught is less than delta, then well, we did all the work already. F of x minus f of x naught, that is square root of x minus square root of x naught, which we were able to transform into x minus x naught over square root of x plus square root of x naught, which now becomes at least less than or equal to x minus x naught over square root of x naught, but now by definition of delta, this becomes less than square root of x naught times epsilon over square root of x naught, which cancels out. And in the end, you get your satisfying epsilon. So what have we shown? So f is continuous at x naught non-zero, but I'm claiming it's even easier to show that f is continuous at 0. So now show f is continuous at 0. So just scratch work what we want. We want f of x minus f of 0 to be less than epsilon, but this is just square root of x minus 0, and that's square root of x, and you want this to be less than epsilon, so x is less than epsilon squared. In fact, x is positive, so we can do that, and then therefore our delta is just epsilon squared. So now let epsilon be given, let delta to be epsilon squared. Then if let's say x minus x naught, which is absolute value of x, is less than delta, then f of x minus f of x naught, again we just saw this as square root of x, but square root of x is less than square root of delta, which is square root of epsilon squared, and that's epsilon. And then we're done. So f is also continuous at 0, so it is continuous at all non-negative real numbers. All right, I hope you like this. If you want to see more math, please make sure to subscribe to my channel. Thank you very much.